Okay, to start off, to quickly review polarity, the difference in the two electronegativities of a bond connecting two elements determines if a molecule is polar or not. If the difference in electronegativities is between 0 and 0.5, it is nonpolar. If the difference is between 0.5 and 1.7, it is considered polar, and if the difference is greater than 1.7, it is considered ionic. Now onto the main concept of the video. There are intermolecular forces and intramolecular forces. The difference is that intermolecular forces are the attractions between neighboring molecules, and its strength also determines the state, which is solid, liquid, and gas. Solids have stronger intermolecular forces than liquids, and liquids have stronger intermolecular forces than gases. Meanwhile, intramolecular forces are forces within the molecule. The pink here shows intermolecular forces, the attraction between the molecules, and the blue represents the intramolecular forces, which are the covalent bonds within the F2. Now, focusing on to intermolecular forces specifically, there are basically three types. Firstly, there's London dispersion forces. We know that in an atom, there's the nucleus and that electrons are constantly moving around in the electron cloud as per the quantum mechanical model of an atom. So this model shows that there are protons and neutrons shown in the nucleus and electrons in the electron cloud, and since electrons move freely, there's a moment where the atom can develop a temporary or instantaneous dipole when its electrons are distributed unsymmetrically about the nucleus. For example, the electrons get on one side and the nucleus is on the other side with positive charge. This will be denoted as partially positive and partially negative. Since there's this one moment where it's positive and negative for one atom, it can also distort the appearance of another atom as the electrons repel each other, which causes another atom to have an induced dipole. So there would be another atom here where there's partially negative and partially positive charge, and this leads to an electrostatic attraction between the two molecules, which is represented by the dots. And since positive attracts negative, and this electrostatic attraction is called London dispersion force. The next type of intermolecular force is dipole-dipole, where there is a polar molecule where the atoms in the molecule have a permanent positive and negative charge, basically a permanent dipole. An example of this is NF3. Fluorine is more electronegative, so it pulls the nitrogen's electrons closer, creating a more negative charge for fluorine atoms and more positive charge for nitrogen atom, which is permanent. Since positives and negatives attract, when there are two of these molecules, they'll attract, and this attraction is called the dipole-dipole. The last type of intermolecular force is hydrogen bonding, which in reality is just a type of dipole-dipole, but more specific to hydrogens. If there's any bonds between hydrogen and a really high electronegative atom, like fluorine, it would create a really polar bond due to the high electronegativity difference. And one example is water. So the hydrogens have a positive charge while oxygens have a negative charge. There's going to be attraction between the positive and negative. This is called the hydrogen bonding. Usually, hydrogen bonding includes HF, HO, or HN bonds. Hydrogen bonds are stronger than most dipole-dipole forces. If written from weakest to the strongest, it would be LDFs, which is the weakest. Then there's dipole-dipole, and then hydrogen bonding.